Hello everyone, this is the question 5 of the important questions and simple answers series. How can you know if the model is overfitting and how to prevent it? Okay, first of all, you can split your data into train, validate and test. Let's look at this part closely. After you splitting your data into train, validate and test, you shouldn't touch test until the model evaluation time. And during the training, you should observe the metrics of train and validate, like loss or validate loss, or accuracy or validate accuracy. Then after the training is over, you should compare the metrics of train and validate. Of course, the easier way is to plotting the metrics over the epochs. So let's look at these two diagrams. As you see, x-axis is for the epochs and the y for the loss, for example, for this graph. But for this graph, the y-axis is accuracy. And the green one is training and the red one is validate. So as you see here, both of them are decreasing. Train loss and validate loss values are decreasing, and after some point validate loss started to increase. So that is the point that overfitting started. So we can understand that our model is overfitting after these number of epochs. For this is same for the accuracy, for example, you can just observe the train accuracy and validate accuracy values. As you see, they are all increasing together, but after some point, after this point, the validate accuracy value started to decrease. So we can easily say that at this point, model started overfitting. So the simple answer, observe the metrics of validate and train and compare them. And if they are increasing or decreasing together, there is no problem. There is no overfitting. But if validate, loss or accuracy or other metrics started to differentiate from the training values, like in this case, validate loss started to increase, that means there is an overfitting here. Of course, you can observe other metrics, but these are the common metrics that helps us to understand the overfitting situation. How to prevent it? There are different techniques, and these are the major techniques: dropout, implementation, drop weight, mesh normalization, or data augmentation. So dropout means disable some neurons during the iterations and make it randomly and based on dropout value. And drop weight is similar. Instead of disabling nodes, in this technique, we will disable the connections, weights, like this. And the mesh normalization is quite important, and especially if the number of layers are too much, then usually mesh normalization helps us to prevent overfitting. And the idea is, for example, subtract mean from input and divide it to standard deviation. And the last one, data augmentation, is quite important. You can just increase the number of data and also diversity. And usually data augmentation increases the performance and prevents overfitting, but of course it can increase also the cost, computational cost. So that's all. See you in the next question.